In this video, we'll take a brief look at the entity relationship model. The entity relationship diagram, or ERD, represents the conceptual database as viewed by the end user. ERDs depict the database's main components: entities, attributes, and relationships. There are several notations used to develop entity relationship diagrams. The most common ones are the ch4 notation, the crow's foot notation, and Unified Modeling Language, or UML notation. The ch4 notation favors conceptual modeling. In the ch4 notation, an entity is represented by a rectangle, attributes are represented by ovals, and are connected to the entity rectangle with a line. Each oval contains the name of the attribute it represents. The crow's foot notation favors an implementation-oriented approach. In this notation, entities are represented by a rectangle. The attributes are written in the attribute box below the entity rectangle. Software vendors have adopted the crow's foot notation as the standard for database diagrams. There are three main types of attributes: simple, composite, and derived. Attributes are also optional or required, and they can be single or multi-valued. We will discuss these different types of attributes. The first type of attribute is the simple attribute. This is an attribute that cannot be subdivided into more attributes. For example, email, sex, and marital status would be classified as simple attributes because their possible values cannot be subdivided into smaller, meaningful units. Email would contain just the email address, such as jdoe@mtuniversity.edu. Sex would be male or female. Marital status would be single, married, separated, divorced, or widowed. Another type of attribute is the composite attribute. This is an attribute that can be further subdivided to yield additional attributes. For example, the attribute address can be subdivided into street, city, state, and zip code. Attributes can also be either optional or required. An optional attribute is an attribute that does not require a value, therefore it can be left empty. For example, student initial is optional because not all students will have a middle initial. On the other hand, some attributes are required. A required attribute is one that must have a value. In other words, it cannot be left empty. In this diagram, all attributes other than the student initial are required attributes. Another type of attribute is a derived attribute. This is an attribute whose value can be determined from other attributes in the data model. For example, an employee's age may be found by computing the integer value of the difference between the current date and the employee date of birth. The dotted line in the model below indicates the employee age is a derived attribute. As the name implies, single-valued attributes can have only a single value. For example, a person can only have one Social Security number and only one date of birth. On the other hand, multi-valued attributes can have many values. For example, a person may have several college degrees, and a car's color may be subdivided into many different colors for the roof, body, trim, and interior colors. This concludes this presentation.